Hello, and welcome to today's webinar on leveraging containers for improved security. This is Christina Cardoza, news editor of SC Times. Before we get started, I have a couple of quick housekeeping announcements. First, if at any time you have any questions about or during the presentation, you may submit them during the controls panel questions tab. Secondly, this webinar will be recorded and available on demand through the sctimes.com website in about 24 hours after the event. Here at SC Times, we're seeing containers being used more and more for delivering and deploying modern applications. Containers provide low overhead, increased portability, more consistent operation, greater efficiency, and faster app development. Today's webinar will look at how an environmental science and engineering consulting company moved its 14-year-old app that models storm surge to containers, as well as how the move simplified and improved the security of its applications, specifics about how containers lowered expenses, and why containers make compliance instantly easier. Here to talk about this more, we have Patrick Maddox. Patrick is the Senior Director of Solutions Architecture at Twistlock. Prior to joining the Twistlock team, Patrick spent 4 years building the SA and PS practices at Puppet and wearing a number of different hats at Verizon. Now to get things started, I will turn it over to you, Patrick.
Thanks for the intro. As Christina mentioned, I'm Patrick Maddox. I'm here to talk to you about our customer. I've done a bunch of different things across my career, sort of spanning some of the sort of legacy applications that this customer sort of represented, and now certainly working in the container space. The focus of today's talk is really going to be the lift and shift approach that this particular customer took to migrating their application. We're going to go through that customer's example, and then we're going to save some time at the end for Q&A. When we say lift and shift, we're just going to sort of set a couple of sort of terms of art for this talk. Lift and shift in this context is the movement of a traditional or monolithic application to containers without going through a process of re-architecting and decomposing the different services that may make up that particular application. In the context of this particular customer, what they did is take their application and really containerize it without doing that decompose effort. The customer made a couple of choices to take this approach. They're sort of evaluating why they might do this and how they can modernize some of their infrastructure. And this approach gave them a couple of advantages. It allowed them to build some experience and momentum with cloud-native technologies. They were already in the cloud, but they sort of pushed them to the next generation of their infrastructure. It improved their automation and efficiency. So they no longer had divergent work streams. So the sort of the new work stream of where every single application they were building was natively containerized, but they were still operating this sort of legacy space where they had none of the benefits of containerization, but they still had to maintain the application because it was still in use by the business. And the thing we're probably going to focus on most throughout this talk is what was this improved security posture? Why did they achieve it? How were they able to achieve it? How do containers give them an improved security posture, even without sort of achieving the sort of idealized state of containerization with very simple decomposed services? So let's set a couple ground rules for kind of what containers are and what the characteristics of containers are in their idealized state. Typically, containers are minimal. They sort of in their most ideal form, they're single process entities. They do only one thing. They're as simple as possible. They're not really attached to sort of in the traditional world of a VMDK, which is a virtual machine. You're not sort of packaging up all of the dependencies that may not relate to the individual application. So typically with a virtual machine, you have drivers and everything that's not really tied to the application's function. Containers tend to be very declarative. They're built from images sort of at their base level that are machine readable, and thus they lend themselves to automation. Because they're declarative in nature, you can very strictly define what they do. And they tend to be also very predictable. They should be doing the exact same thing from the time they're instantiated to the time they're ended, and it should be consistent across the entirety of their life cycle. So if you spin up another container that is from the same image, it should do the exact same thing that a previous container from that image did, unless you somehow revved the build or changed the functionality. There are a couple things that are different about securing containers, sort of first principles. There are many more entities typically. Sort of if you take a monolithic application and start decomposing it into the various services that make up that application, you end up with a lot more entities. And typically you're also running more copies of those entities. So in this particular example, we have a customer who's taken their monolithic application and put it into containers, but they may end up running more of those actual containers to satisfy a load requirement. Containers typically experience a higher rate of change, or really the images underneath them experience a higher rate of change. So the objects that you're working with tend to be more ephemeral. They tend to not live a long time. So sort of traditional world, you may have a virtual machine that stood up and patched continuously across its lifetime for many years in many cases. Containers, you will shut down or you roll out a new copy of that object you spun up. And the patching occurs way more upstream. So we're not attached to the concept of an object living for a long time. Security is largely in the hands of the development organization, or certainly very tied to the developers. The developers are who typically make changes to the images that are eventually instantiated as containers. And security has to be just as portable as the containers. Certainly with the advent of orchestrators, you have workloads that move around quite frequently depending on where a workload is scheduled to run. And as a result, you have to have security that is sort of natively built into the way of working within containers. So you can't sort of rely on IP addresses consistently as the sort of canonical identifier for a workload. It's much more associated with the image, and everything has to be automated because everything is more ephemeral. So let's return to the customer example. We're going to walk through what made this particular customer unique, and we already covered a little bit of it in the intro. But some more details on this. This is a customer of ours who they had this application that started probably 12, 14 years ago. It started as physically manifested in their data center on IBM hardware. Eventually, it was moved to virtual machines again in their data center, and eventually they moved that workload over to Azure, a cloud service provider. This application didn't sort of remain static across that time. It initially started as a waterworks application. So how do you model water flows? How can it be used to engineer civil works effectively? Even though it probably started, or we know it started as a sort of simplistic thing, new features were added over time, and thus new dependencies. And it was certainly built around a much older version of Java when it was initially built, and then that was eventually revved over time. So you have a number of different dependencies, but this application is really consumed by a user base that is scattered around the globe. It is sort of mission critical dependent, and that's how they generate a significant portion of the revenue. Because this application is so critical to the customer, it had a couple of challenges with securing it. Sort of fundamentally, they had some trouble maintaining consistency across the variety of different environments that this application was deployed in across its life cycle. That deployment was very difficult and resource intensive. You were typically working off of a run book across each stage. You didn't have teams that were responsible for each individual environment that were communicating natively. You were highly dependent on what the sort of underlying infrastructure was and how consistently it was configured. The build process couldn't be automated. Some parts of it were, but ultimately the deployment was, again, very sort of run book focused. I mean, this is a 14-year-old application, and just because it's this application, it's something that's very common to enterprise. They have an application that the business relies on, but business has an understanding of how to run it, but actually rolling out new revs and everything else takes a long time. Some businesses are happy if they can achieve a quarterly release cycle. That's sort of their idealized state. Because the deployment was so complicated and so interdependent, disaster recovery was very complicated. It wasn't so simple to spin up a new instance of the virtual machine. You had to sync with a number of different tiers that are involved in the application's actual rollout. So a data tier, a caching tier. You had to make sure you had very sort of consistent backups. Perhaps they weren't tested very consistently. It wasn't ultimately, at the end of the day, the core problem was it wasn't automated, and it wasn't easy to automate. And then finally, you've got all these complications with securing the container, because there's a lot of operational concerns, but also sort of like, how does the application actually work? At the end of the day, the data within this application, the user base for this application, really put everybody at a disadvantage. So the customer was at a disadvantage when it came down to it. This application held data that was sensitive, so you had a number of compliance regimes that applied. The user base for this application wasn't sort of internal. You couldn't have this application behind a firewall. It had to be accessed from various entities around the globe. And as a result, there were no real sort of inherent advantages to the defender in this case. Every sort of advantage was naturally to the attacker. So the customer explored a number of ways of addressing some of these shortcomings and sort of the challenges they had with running this particular application. And ultimately, they decided to repackage the application as a container. We're going to focus on the security benefits they saw. Sort of the purpose of this is really to talk about the security benefits. And they really fell into three main buckets of benefits: vulnerability management, compliance, and the one we'll spend the most time with really is probably threat protection. So let's go into these in a little more detail. Let's sort of examine the differences between the traditional approach for these areas and the modern approach for these areas. The traditional approach for an application, and this customer certainly experienced it, was vulnerability scanning was done after every build. It was a sort of divorced workflow from the sort of natural building of this asset. Operations and development didn't have bidirectional visibility into the vulnerability posture. So one team is aware of the vulnerability posture in one aspect of the container or of the application's lifecycle, but not in I would say a previous sort of build stage in the application's lifecycle. And ultimately, everything was very reliant on point-in-time scans. And the modern approach to this is very different, and the customer saw these benefits. They were able to integrate vulnerability scanning into their pipeline, so they sort of get the ability to pass or fail builds based on the vulnerability posture as a natural part of their automated build process. So sort of automation is a first-class citizen here. That automated blocking of builds when vulnerabilities exceeded thresholds allowed a developer to immediately get feedback without diving out to another tool or another set of workflow pieces. They were able to see in the tooling they were naturally used to working with kind of the vulnerability posture of the images and fix them immediately, just kick off another build. And ultimately, sort of the biggest sort of benefit that this customer saw was you got the development team and operations team working from the same context of data, visibility into the vulnerability posture of the running applications, but also the state of vulnerability management across the image's lifecycle by referencing the same data, using the same tool across that image's lifecycle. If we jump over to compliance, we see some similar benefits, but there's some different sort of aspects to the compliance management. So much like the previous example, operations owned compliance. They were ultimately the ones to make sure that data was protected and everything else. Because operations owned compliance, there was a lot of manual feedback to development teams, sending an email, send a report, operating off of that report. At the end of the day, the compliance was all sort of manual runbook driven. You work from a 45-page runbook to make sure the application is in compliance with the current standards. It's really only done at operations time. It's all sort of related to an individual writing something down reliably. And there's really no version control of the application. Again, we're back to that state of point-in-time checks. The modern approach to this is, again, that shared ownership throughout the lifecycle. Operations can define the rules. Development tools like Jenkins enforce the rules automatically. You can validate that only trusted components are allowed in production. So the classic example here is, running an old version of Java or an old version of a Java component. You can enforce whether you're running the latest versions of these components. You're not sort of reliant on on just sort of patching it to make sure it works. You can sort of insert all these policies throughout the entirety of the life cycle. And as I mentioned before, you end up with a shared and central view into the compliance state of all the assets in the environment across the entirety of the life cycle, whether that's in the CI system, whether that's checked into a registry, whether that's actually running in production. And the customer uses Twistlock for all of this. So we've talked a lot about the compliance issues. We talked a little bit about the vulnerability issues. Twistlock is sort of the backbone for all of these. Twistlock has the capabilities and really what the customer is taking advantage of across the entirety of the life cycle in a singular tool set that gives them a lot of these advantages. The last thing to talk about, the last sort of core advantage is threat protection. So you've got the sort of making sure your assets aren't vulnerable, making sure that you're operating that application such it's compliant with the compliance regimes you're working under. But you've got a bunch of other advantages that Twistlock brings and this approach brings to threat protection. The traditional mechanisms for threat protection tend to be very edge focused. You've got and very sort of manual rule driven. You've got an IDS or IPS system that may be configured properly initially, but those rules inevitably begin to rot over time. They are less accurate over time. And certainly as an application lives throughout its life cycle, new components are spun up, new systems are retired, you end up with an overly permissive state of rules. You're reliant on perimeter systems. So you're not embedding security into the application itself. You're reliant on perimeter controls and segmentation of infrastructure. And those perimeter controls and segmentation of infrastructure typically have very limited anti-malware capabilities. They're looking at data as it crosses the wire, but not necessarily how things are performing on the actual hosts and applications itself, or that's an entirely separate tool set. It's not integrated. And again, you're dealing with manual rule creation. So all of this traditional protection is very sort of human dependent and very policy driven, and thus is very prone to error because automation isn't the default. Let's talk a little bit about the modern approach. The modern approach, it uses automation at its core. And this is what Twistlock does. Twistlock's threat protection is whitelist based. It's tied to every build. You end up with the minimum permissive set required for an application to function across a number of dimensions of that application. And, you know, we look at the processes, the network connectivity, the file system persistence, the system calls. All that is automatically built in, configured every single time a new build's released. The modern approach also embeds layer 3 and layer 7 firewalling into the container ecosystem itself. The containers and host rules are all created automatically. They're all deployed at scale. They're all based on observing how an application actually functions versus someone's interpretation of how it should function. And having automation as the core first-class citizen means that you're not in this maintenance mode and big operational burden, figuring out which rules need to be removed or which rules need to be added, because the tooling, and in this case Twistlock, is automatically doing it itself. All of this is to say there's a number of inherent security benefits that you can achieve by just taking that monolithic application and putting it into containers. You end up with machine readable formats. You end up being able to apply automation across the life cycle. Using a tool like Twistlock, you get the ability to inject security at every stage of the life cycle, creating common reference data for all the parties responsible for different parts of the tool, of the application itself. And then you get all the operational benefits where you can start bringing legacy applications into the new way of actually how most organizations are going to be running the operations of their business, being very cloud native and container centric. And now we have some time for Q&A, and I'll open it up to the moderators to give us a hand.
Great, thanks, Patrick. Just a reminder, if you have any questions, now's the time to ask them through the control panel's questions tab. So, Patrick, why is it important to use security tools built for the container ecosystem?
Yeah, no, that's a great question. Well, so there are a couple of reasons it's important. I mean, sort of first, primarily something I alluded to a whole bunch is automation. The container ecosystem is sort of naturally built to be automated. And as a result, you need a tool that sort of treats automation as a first-class citizen. That's really what Twistlock does. The other thing is traditional security tools tend to be very point-in-time focused or very sort of individual asset focused. So you may tie a lot of your scans to a specific host name or a specific IP address. In the context of an orchestrated infrastructure, those references don't really matter as much, or at least they change a lot more. And if you don't have a tool that natively understands containerization, containers in the ecosystem that cloud native implies, you end up with a bunch of challenges sort of in terms of maintenance and operations. And so you really have to take two sort of core approaches. You have to integrate security across the entire life cycle, and then you have to have a tool or a tooling platform that like Twistlock that does security across from the host operating system all the way up into individual processes inside instantiated containers. And so Twistlock's covering that full spectrum, both left to right and top to bottom.
Great. So can you decompose your monolithic applications over time, or is it still necessary?
Yeah, I mean, I think what we see our customers who are doing the lift and shift approach is they're starting out with the lift and shift approach, and then they're figuring out what services they don't want to actually have embedded in that monolithic application. So they may pull a given service out of it because it gives them an opportunity to unify how services are being run, or remove a built-in dependency to that application. And I think sort of what customers are trying to figure out is, how do I go from my legacy space where everything's effectively virtual machines into a containerized space? And this is really the path for doing that. They don't necessarily have to, but I think that's certainly what we're observing across our customers is once they get their monolithic applications into containers, they start figuring out which parts of it they can pull out into individual services, because naturally that just makes it easier for them both to operate, but also rev individual components independently and sort of move faster naturally.
And how do you deal with new builds?
No, Twistlock treats new builds as a new object. So when we say we're backed by automation, you effectively sort of reestablish a zero trust sort of level when there's a new build comes out, and you kind of have to. I mean, Twistlock of course gives you the ability to create policies and apply them to any sort of the natural references within a cloud native workload or cloud native environment. So you can create your own policies that apply broadly or generically, but by default, we don't trust anything. And so let's say you issue a new build. Well, we're going to go ahead and say rescan that or scan that new build, so we get a complete manifest for all the components of the build, and thus we can apply up-to-date vulnerability information in real time. We're not going to trust whether that new build has the same functionality. And so we're going to use our automation built into the product to automatically build that whitelist security model, looking across a number of different dimensions of container behavior to assemble the sort of the runtime model for whether a container is behaving as we expect, even if it's just a new build. And that's how you can have security that is very mature, taking advantage of all the benefits of containerization, but not sort of get trapped in this space where you're constantly maintaining policies and everything else, which ultimately either causes you to give up on some of your security because it's slowing you down, or sort of not implement it fully. And so that's kind of why a new builds and sort of automation matter.
Great. Before we wrap things up, I just want to quickly throw it back to you one more time, Patrick, for a final thought or key takeaway you'd like to leave our attendees with today.
Sure. The final thought I would say is you don't have to make sacrifices when it comes to your legacy applications and moving them into this new world. You actually a ton of benefits. And one of the core benefits is you get a lot of security benefits. It's sort of certainly you can move faster. Certainly you start aligning kind of how you actually operate infrastructure with the new way of doing things. But ultimately, this move to containerization gives you a huge number of security benefits that are available across the life cycle when you use Twistlock to do it. And you end up with the full lifecycle approach to security and the full security stack from the sort of base operating system through the cloud service provider, through the container runtime, through the orchestrator, all the way up into the applications actually instantiated, actually inside instantiated containers.
Great. Well, thank you for a great presentation today. Again, that was Patrick Maddox, Senior Director of Twistlock Solutions Architecture. I would like to thank Twistlock for sponsoring today's webinar and the attendees for joining us today. Until next time, I'm Christina Cardoza with SD Time.